Welcome to my channel. In this lesson, we're going to be focusing on calculations on kinematics. Let's start with this question. The position of a particle is given in meters by this equation: x equals to 9.75 plus 1.5 t cubed, where t is in seconds. Find the instantaneous acceleration at t equals to 3 seconds. So the equation of the position we're given is x equals to 9.75 plus 1.5 t cubed, and then the time is 3 seconds. Now, to get the instantaneous acceleration, we're going to find the second derivative of this position. So we're going to differentiate this position with respect to t twice. So that is the second derivative of this x. So let's first of all start with the first derivative, dx dt. So if we differentiate 9.75, we're going to get 0 because that's a constant. If we differentiate 1.5 t cubed, we're going to get 4.5 t squared. So you see the way I did it. If you have y equals to t raised to power n, then to differentiate this with respect to t, we are going to multiply the coefficient of this t by this exponent n. So in this case, n times 1. Then you multiply everything by t raised to the power of, then you remove 1 from this n exponent, so it's going to be n minus 1. So this is what I did here. Now this is going to be equals to 0 plus this is equals to 4.5 t squared. So let's find the second derivative. So the second derivative, the square x over the t square, is equals to, we're going to differentiate this now. So 2 times 4.5 is equals to 9, then 2 minus 1 is equals to 1. So we have that instantaneous acceleration, which is equals to the square x over the t square, is equals to 90. If you plug in the value of t, which is 3, into this, we're going to have 9 multiplied by 3, which is equals to 27 meter per second square. So this is the instantaneous acceleration. Question number 2. A particle moves in the y direction. If the motion is represented by y equals to 3.10 t plus t squared in meters, what is its velocity after 10 seconds? I want you to solve with me. So the position equation we're given is 3 plus 10t plus t squared, and then the time is 10 seconds. Now the last question we solved was acceleration. Here we have to find the instantaneous velocity. Now the instantaneous velocity is equals to the first derivative of position, so that is dy dt. Now if you differentiate this is a constant, so it's going to be equals to 0. If you differentiate 10t, 1 times 10 is 10, then 1 minus 1 is 0, t raised to power 0 is 1, then you have plus t squared. If we differentiate it, you're going to have 2t. So you have that instantaneous velocity is given by this equation, 10 plus 2t. So this is the equation for instantaneous velocity. Now if you plug in 10 for t, we're going to get 10 plus 2 times 10. So the instantaneous velocity is equals to 2 times 10 is 20, 20 plus 10 is going to be 30 meters per second. So this is the answer to this question, which is choose option C. A ball is thrown vertically upwards with a speed of 39.2 meters per second. Find the elapsed time before the ball returns to its original position. We know the solution. From the question, we are given initial speed as 39.2 meters per second. So is there another thing we know here? We are going to take acceleration due to gravity as 9.8 meters per second square. Now we're going to use this equation. S is equals to initial velocity times time plus half AT square. So we have, let's represent this S with H. So this will be equals to initial velocity times time. Now this acceleration is going to be A equals to negative G, because upwards motion opposes gravity, so it's going to be negative. If we plug in A to be negative G, we're going to have negative half gt square. Now let's get back to the question. The ball is thrown vertically upwards with the speed of this. Find the elapsed time before the ball returns to the ground. Now it means that this ball was, let's assume that this is the ball, it was thrown up, right, and then come down. So there's no vertical displacement here. Okay, since the ball returns to its original position, the height is going to be equal to 0. But assuming the ball returned somewhere here, then this is going to be the displacement. So but since it returned to its original position, then it's going to be 0. Then equals to initial velocity from the question is 39.2, then multiplied by the time is what we're looking for, then minus half times 9.8, then multiplied by t square. So let's factor out t. We have t here and we have t square here. If you factor out t, we're going to get 39.2t divided by t. We have 39.2, then minus all of these divided by t. We're going to get half multiplied by 9.8, then t equals to 0. So I have that either t is equals to 0 or 39.2 minus, now 9.8 divided by 2 is 4.9, then t is equals to 0. So let's take this to the right hand side. We have 39.2 equals to 4.9 t. So let's divide both sides by 4.9. Then this and this will cancel. We have that t is equals to 39.2 divided by 4.9. This is equals to 8 seconds. So this is the answer to this question. Now this t equals to 0. What it means is that at this point when the ball is being thrown up, the time there is 0, just like the starting time is 0. That's what this t equals to 0 means. So the answer here is just option B, 8 seconds. An object undergoes a constant acceleration after starting from rest and then travels 5 meters in the first second. Determine how far it will go in the next 1 second. Then solution. Now for clarity, let me illustrate this question. So let's assume that this object started at this point A, right? They say it started from rest and then travels 5 meters. So let's say that from this point A to this point B is 5 meters in the first seconds. So this is when time is equals to 1 in the first second. Determine how far it will go in the next 1 second. Let's assume that in the next 1 second, this object is at this point. Let's name this point C. So in the first second, this ball, the object, travel from here A to B. Now we have to determine how far it will go in the next 1 second. So that means that from this point A to this point C is equals to 2 seconds. Alright, is equals to t. That's time here is equals to 2 seconds. 1 second from here to here, and then another 1 second from here to here, because the question says in the next 1 second. So since we know the distance from this A to B, we are going to find the distance from this A to C. So what we are asked to determine is the distance from here to here. That's how far it will go in the next 1 second. We get the distance from this A to C. We are going to subtract the distance from A to B, and that will be the answer to this question. I hope you get it. this is what we're looking for. So let me say that this is S1 is equals to 5 meters. We're going to find S2, all right, at t equals to 2 seconds. So let's start. We have that S1 is equals to initial velocity times time plus half a t square. Now from the question, the first distance S1 is equals to 5 meters. So I have that S1 is equals to, now initial velocity is equals to 0 because it started from rest. So this is going to be, this is 0, we now have half a t square. So we are going to solve for acceleration here, alright, because we know S1 as 5 meters, we know time as 1 second, that's in the first second, but we don't know acceleration. So let's find acceleration. Let's plug in the values we have. So this is 5 equals to half a down t is 1 square. So if we multiply both sides by 2, this and this will cancel. 2 times 5 is equals to 10, equals to a times 1 square is a. So acceleration is equals to 10. Now let's use this equation again and then find the second distance. So S2 is equals to half times acceleration is 10 multiplied by time square. Here time is 2, so this is 2 square. I have that S2 is equals to half times 10 times 2 square is equals to 4. So 10 divided by 2 is 5. 5 times 4 is 20. So S2 is equals to 20 meters. Now this displacement, this alpha we asked to find, is going to be S2 minus S1, which is 20 minus S1 is 5. Now this is equals to 15 meters. So this is the answer to this question. A stone is thrown with a velocity of 50 meters per second upwards from a point 20 meters above the ground. When does the stone reach its maximum height? So we have solution. We're given acceleration to gravity as 9.8 meters per second square, and then the initial velocity is given as 50 meters per second, and then the height is 20 meters. Let me illustrate this question. Let's assume that this is the throne that was thrown up, and then it reaches at this point and then started falling down. Okay, so what the question asks us is to find the time it took this stone to reach this point. This is the maximum height that this stone reached before descent. So we are going to use this formula. Final velocity is equals to vi plus at. Now this acceleration is going to be negative g because the motion is upwards and that is opposite gravitation. So we're going to have final velocity is equals to initial velocity minus gt. So this final velocity at this maximum height is going to be 0. Then we have initial velocity minus gt. So let's add this to both sides. If you revise this, you're going to get vi is equals to gt because this and this will cancel. Alright, now let's divide both sides by g since we're looking for time. So I have that t is equals to initial velocity divided by g. Initial velocity here is 50 and g is 9.8. So 50 divided by 9.8, this is equals to 5.102 seconds. So this is the time it took this stone to reach this maximum height. The velocity of a space vehicle changed from this to this in 10 seconds. Its acceleration is 10.7 meters per second square. How far did it move between t equals to 2 seconds and t equals to 6 seconds? So here, this 55.0 is the initial velocity. So initial velocity is equals to 55.0 meters per second. And then the final velocity is equals to 160.0 meters per second. Now the time is 10 seconds from the question, and then the acceleration A is equals to 10.7 meters per second square. Now we're asked to find how far it moved between when t equals to 2 seconds and when t equals to 6 seconds. So we're going to find the displacement when t equals to 2 seconds and the displacement when t equals to 6 seconds, and then subtract it. So let's start with this displacement formula. We have that s is equals to initial velocity times t plus half a t square. Now at t equals to 2 seconds, we have s sub 2 equals to initial velocity is 55.0 multiplied by time is 2 plus half times acceleration is 10.7, then multiplied by t square. So if you plug this in your calculator, you are going to get 131.4 meters. Now when t is equals to 6, we're going to have s sub 6 is equals to 55.0 multiplied by 6 plus half multiplied by 10.7 multiplied by 6 square. If you plug this in your calculator, we're going to get 522.6. Now the displacement is now going to be s6 minus s2. So this is going to be 522.6 minus 131.4. This is equals to 391.2 meters. Thank you for watching. Please subscribe to my YouTube channel, like my videos, and share with your friends. Don't forget to drop your comments. Have a nice day.